So let's take our equation in the form y prime plus p of xy, the general form, using the old variables equals q of x. Solve me. Well, there are different ways of describing the solution process. No matter how you do it, it amounts to the same amount of work. And there's always a trick involved in each one of them, since you can't suppress a trick by doing the problem some other way. The way I'm going to do it, I think, is the best. That's why I'm giving it to you. It leads to, it's the easiest to remember, leads to the least work, but I have colleagues who would fight with me on that point. So since they're not here to fight with me, I am free to do whatever I like. One of the main reasons is that of doing it the way I'm going to do is because I want you to get one more word into your consciousness, and that's the word, two words, integrating factor. I'm going to solve this equation by finding an integrating factor of the form u of x. What's an integrating factor? Well, I'll show you, not by writing an elaborate definition on the board, but showing you what its function is. It's a certain function u of x. I don't know what it is, but here's what I want it to do. I want to multiply, I'm going to drop the x's just so that the thing looks less complicated. So what I want to do is multiply this equation through by u of x. That's why it's called a factor, because you're going to multiply everything through by it. So it's going to look like uy prime plus p u y equals qu. And now this thing is, so far it's just a factor. What makes it an integrating factor is that this, after I do that, I want this to turn out to be the derivative of something with respect to x. You see the motivation for that. If this turns out to be the derivative of something because I've chosen u so cleverly, then I'll be able to solve the equation immediately just by integrating this with respect to x and integrating that with respect to x. You just then integrate both sides with respect to x, and the equation is solved. Now, the only question is, what should I choose for u? Well, if you think of the product formula, there might be many things to try here, but there's only one reasonable thing to try. Try to pick u so that it's the derivative of u times y. See how reasonable that is. If I use the product rule on this, the first term is u times y prime. The second term would be u prime times y. Well, I've got the y there, so this will works if what? If, what's the condition that u must satisfy in order for that to be true? Well, it must be that after I do the differentiation, u prime turns out to be p times u. So is it clear? This is something we want to be equal to, and the thing I'll try to do it is by choosing u in such a way that this equality will take place, and then I'll be able to solve the equation. And now, so here's what my u prime must satisfy. Hey, we can solve that, but please don't forget that p is p of x. It's a function of x. So if you separate variables, I'm going to do this. So what is it? du over u equals p of x times dx. If I integrate that, so separate variables, integrate, and you're going to get du over u integrates to be the log of u, and the other side integrates to be the integral of p of x dx. And you can put an arbitrary constant there, or you can think of it as already implied by the indefinite integral. Well, that doesn't tell us yet what u is. What should u be? Notice I don't have to find every possible u which works. All I'm looking for is one. All I want is a single u which satisfies that equation. Well, u equals the integral e to the integral of p dx. That's not too beautiful looking, but by differential equations, things can get so complicated that by the, in a week or two, you will think of this as an extremely simple formula. So there's the formula for our integrating factor. We found it. We'll always be able to write an integrating factor. Don't worry about the arbitrary constant because you only need one such u. So no arbitrary constant since only one u needed. And that's the solution, the way we solve the linear equation. Okay, let's take over and actually do it. I think it would be better to summarize it as a clear-cut method. So let's do that. So what's our method? It's the method for solving y prime plus py equals q. Well, the first place, make sure it's in standard linear form. If it isn't, you must put it in that form. Notice the formula for the integrating factor. The formula for the integrating factor involves p, the integral of p dx, so you better get the right p. Otherwise, you're sunk. Okay, so put it in standard linear form. That way you'll have the right p. Notice that if you wrote it in that form and all you remembered was integral e to the integral p dx, the p would have the wrong sign. That, if you're going to write that p should have a negative sign there. So do it this way and no other way. Otherwise you'll get confused and get wrong signs, and as I say, that will produce wrong answers, and not just slightly wrong answers, but disastrously wrong answers from the point of view of the modeling, if you really want answers to physical problems. So here's a standard linear. Then find the integrating factor. So calculate e to the integral p dx, the integrating factor. And then multiply both. I'm putting this as both. Underline that as many times as you have room in your notes. Multiply both sides by this integrating factor by e to the integral p dx. And then integrate. Okay, let's take a simple example. Suppose we started with the equation xy prime minus y equals, I had a x squared, x cubed, something like that. X cubed, I think. Yeah, x cubed. Okay. What's the first thing to do? Put it in standard form. So step 0 will be to write it as y prime minus 1 over x times y equals x squared. There are two standard errors. Let's do the work first, and then I'll talk about mistakes. And now what? Well, we now calculate the integrating factor. So that's, I would do it in steps. You can integrate negative 1 over x, right? That integrates to minus log x. So the integrating factor is e to the integral of this dx. So it's e to the negative log x. Now in real life, that's not the way to leave that. What is e to the negative log x? Well, think of it as e to the log x to the minus 1. Or in other words, it is e to the log x is x. So it's x to the minus, so it's 1 over x. So the integrating factor is 1 over x. Okay, multiply both sides by the integrating factor. Both sides of what? Both sides of this, the equation written in standard form, and both sides. So it's going to be 1 over x y prime minus 1 over x squared y is equal to x squared times 1 over x, which is simply x. Now, if you have done the work correctly, you should be able now to integrate the left-hand side directly. So I'm going to write it this way. I always recommend that you put in as an extra step, well, I won't. Put in as an extra step the reason for using that integrating factor. In other words, that the left-hand side is supposed to be now 1 over x times y prime. I always put in that because there's always a chance you made a mistake or forgot something. Look at it, mentally differentiate it using the product rule just to check that in fact it turns out to be the same as the left-hand side. So what do we get? 1 over x times y prime plus y times the derivative of 1 over x, which indeed is negative 1 over x squared. And now finally, that's 3a. Continue, do the integration. So you're going to get, let's see if we can do it all on one board. 1 over x times y is equal to x plus a constant, x squared over 2 plus a constant. And the final step will be, therefore, I now want to isolate y by itself. So y will be equal to, multiply through by x cubed over 2 plus c times x. And that's the solution.